Hey everyone, today we are diving into SageMaker Pipelines, AWS solution for automating end-to-end machine learning workflows. If you are manually running training scripts, copying data between S3 buckets, and trying to keep track of which model version had which matrices, this video is for you. We are going to build a production-grade ML pipeline that handles everything from data pre-processing to model training to model registration, completely automated. Let's jump in. So what exactly is a SageMaker pipeline? Think of it as a DAC, or directed acyclic graph, where each step in your ML workflow is a node and SageMaker automatically handles the execution, data flow, and dependencies between them. Our pipeline has three main steps: pre-process data, train model, and model registration. The beauty here is that SageMaker handles all the compute provisioning, data passing between the steps, and tracks everything. No more manual coordination. Let's dive into the code. First, the pre-processing. We are using a script processor that runs our preprocess.py script on a managed compute instance. This is how our preprocess.py looks like. Now notice that how we define the processing inputs. We are pulling our raw train, test and validation Parquet files from S3. The processor runs our script and then processing outputs automatically saves the processed data back to S3 in the data folder. The key thing here is that we are not hard coding anything. Everything comes from our pipeline config YAML file. This means changing datasets or instance types is as simple as updating one config file. Infrastructure as code at its best. Next, the training step. We are using SageMaker's HuggingFace estimator, which comes pre-configured with PyTorch and transformers. This is how our train.py looks like. Also, we are using step preprocess.properties to dynamically reference the outputs from the previous preprocessing step. This creates a dependency change. SageMaker knows it can start training until preprocessing completes. And if preprocessing fails, the whole pipeline stops. No wasted compute, no partial runs. The estimator automatically provisions a GPU instance in our case, which is a G4 instance. It runs the training and saves the model artifacts to S3 bucket, all logged and tracked. Finally, model registration. This is a huge for production ML. We are using register model to push our trained model into SageMaker's model registry. A few critical things happen here. First, we automatically attach the model matrices. This means that every registered model has its own performance matrices, F1 score, precision, recall, permanently attached to it. Second, the approval status is set to pending manual approval. This is basically a governance gate. Before this model can be deployed, someone needs to review those matrices and explicitly approve it. And third, we are specifying which instance type this model can run on for inference. This prevents someone from accidentally deploying a model on an instance that's too small or too expensive. All of this metadata makes the model registry a single source of truth for model versions, performance, and deployment history. Now let's bring it all together. These three steps get packed into a pipeline object. When we call pipeline.upsert, SageMaker creates or updates the pipeline definition in the account. Then pipeline.start kicks off an execution, and this is completely serverless. SageMaker handles the scaling, retries, logging, and everything. Let me show you what this looks like in a SageMaker Studio. Here you can see all three steps, their status, execution time, and you can click into any step to see logs, inputs, outputs, and matrices. You can also see our model now sitting in the model registry with all its metadata. And that's SageMaker Pipelines. We went from manual script execution to a fully automated ML workflow. This same pattern works for any ML use case, computer vision, NLP, time series forecasting, or anything that you can name it. Thank you for watching.